The following short video is a first-hand account of a technology breakthrough I was privileged to be invited to. The footage in this video has been shot and edited by myself, and I personally vouch that it's an accurate and unbiased representation of what took place that day. This following PowerPoint presentation was given on the day by the inventor of the technology himself. Because all of the attendants other than myself were Thai nationals, the presentation was given in Thai language. The slides, however, are in English.
สูบน้ำกับน้ำมันเข้าด้วยกันดีน้องก็มีเสิร์ฟเพื่อนมาให้ดูจากสวัสดิ์วันเดี๋ยวน้ำมันพวกนี้ครับเราก็จะเอาไปเทสอันนี้คือเอาให้ดูว่าอันนี้ที่ผสมมาแล้วเราลงไปเทสไม่ได้ผมคุยก่อนแต่กลิ่นมันจะเหม็นนะกลิ่นมันจะเหม็นมันจะมีแป๊บเดียวได้เห็นรูปครับเดี๋ยวเห็นรูปแป๊บเดี๋ยววางแป๊บเห็นรูปโอ้โหพวกมันเหม็นอันนี้จะเป็นน้ำมันดีเซลครับที่ยังไม่ได้ผสมน้ำอันนี้ดีเซลผสมน้ำ50% 60-40%อันนี้เป็นน้ำมันเตาสีก็จะอันนี้น้ำมันเตาผสมน้ำแล้วอันนี้มีน้ำอยู่ 50%สังเกตว่าอันหนึ่งที่ผมให้ทุกคนเห็นเนี่ยมันเป็นสิ่งซึ่งทางที่นี่เองเราก็จะของอันนี้เป็นน้ำมันเตาธรรมดาน้ำมันดีเซลไม่มีเลยครับสีต่างอย่างเดียวแต่ทุกอย่างเหมือนกันอันนี้น้ำมันเตาธรรมดานะครับไม่มีอะไรเดี๋ยวผมพาเข้าไปให้ดูนะอันนี้เป็นน้ำมันเตา 50% สังเกตดูนะครับว่าความเหนียวคนละเรื่องเลยอันนี้ความเหนียวประมาณ 1,000 เซนติสโตรกอันนี้ความเหนียวประมาณเกือบ200น้ำมันเตาสี
How many percent is in it?
50%. That is 1,200 centistork when mixed with the water.
That's with your special
yes.
mixer.
That is we have a problem on viscosity because อันนี้
Of course.
ความหนืดมันเดิมทีจาก100กว่าน้ำมันดีเซลง่ายๆครับ2-3อันนี้200อันนี้ไป1,000 กว่าอันนี้ผสมอันนี้น้ำเปล่าอันนี้ไม่ใช่น้ำเลยอันนี้ไลมอนวอเตอร์ดูนะครับเหนียวมากฮะเหนียวขึ้นเหนียวดูนะครับคนละเรื่องอันนี้แบบเร็วๆอันนี้แบบเป็นแบล็คเลยฮะอันนี้200 เซนติโตรกอันนี้1,300 1,200แล้วเดี๋ยวส่งมาดูกันครับเพื่อนนี่ไปอันนี้เป็น50-50อันนี้เป็นน้ำมันเตา 100%ส่วนดีเซลไม่มีเลยครับดีเซลมัน
On an engine. So first, the engine is started up and run on just pure diesel to give a baseline test for the fuel consumption. So you'll notice the engine surges a bit at first because the fuel lines have just been disconnected from the actual fuel tank, and they've got air in them, so you've got to purge out a little bit. As soon as that happens and there's no air in the system anymore, you will find the engine runs steady. And what we're going to observe then is by how much the fuel drops in the clear container from one graduation to the next in how many seconds, and that's how we can then calculate the total fuel consumption. So the engine is running stable now. So I've done a close-up here to observe how fast the fuel is being consumed. We're having 250 milliliters in the container between one line and the next. And testing with the stopwatch, it turns out that it takes about 30 seconds for 2 lines. So 30 seconds for half a liter of fuel, which means 60 liters of fuel are being consumed per hour, generating 200 kilowatt hours of power. The generated power is just over 66 kilowatt per phase, and the total 199.5 kilowatts roughly being generated. This time the display switched over to display volts, so we got 400 volts being generated at about 50 Hertz nominal. The next test is testing the water fuel. This time the guys make sure that the fuel line gets completely purged from diesel, so they've checked that out of the return line comes pure water fuel. That's what we saw a second ago. And the water emulsion is now poured into the same clear container there. So the fuel lines get changed over. So the engine's running now on 50% water and 50% diesel. So once again, here we can see how quick the fuel is being consumed. So as I said, the engine runs at exactly the same load as before. I've verified that. I checked the meter on the load bank, and we can see the rate at which the fuel drops between one line and the next. With absolutely no visible pollution from the exhaust at all. It's just completely clean. Not the slightest bit of smoke or opacity. You can only just see flimmering heat waves there. Okay, on this slide here, we can see two screen captures 30 seconds apart, which show that half a liter is consumed after 30 seconds, and that same for the diesel and for the diesel water fuel. It just consumes the fuel at the same rate. On the left is 50 dump oil and 50 water. And on the right is just pure diesel. As you can see, it's very hot and clean. There's no smoke or anything. Wider flame on the water. Okay, now we're coming to the car demonstration. So they just disconnected the fuel lines from the tank and connected the intake line into a clear plastic bottle that's mounted in the engine bay. You can see now that to the fuel filter the water emulsion fuel is coming in. At the same time, they're making sure that all the diesel fuel is purged from the system, and that's what we can see now. So here I want to check how clean the engine runs with the fuel. So I've asked the guys to rev the engine up rapidly and I give it a flick with the throttle. They don't quite understand that yet, but in a second they will give it just a rapid acceleration and you will see it creates very little pollution. It's very, very clean.
I want him to give it quick acceleration, not carefully. Just put your foot on like, you know. Okay.
One more. See no maximum?
Yeah, it's good.
It's good, right?
So this is a performance test, so I drove in the car as a passenger to get a feel for it.
For sure.
And if
Not
this
13.
car would have had any loss of power or reduction in power due to
Pulls
the
very
water
well,
not,
got good pickup.
or the water subtracting from the heat value of the fuel, certainly would notice that with a 3-liter diesel engine. While they're reasonably good performer, they're not exactly a ball of fire, so like a reduction of 20% or 50% in power would certainly be noticeable with this, and this thing went like a bat out of hell, really.
What about using than before?
It seems to pull better than before.
This is the last test, the burning rubber test. So as you can see, the thing goes quite well, even though it runs on 50% water. So I was quite impressed.
Very good.
Compare this before.
Pardon?
Now.